Okay, here's another example for you to try. So in a minute I'll have you pause the video and read through it, work through the test, and then you can start the video back up and see how you did. Good luck. Okay, so let's see how you did here. This says the diameter of a screw must measure on average 0.400 centimeters. A sample of 45 screws is selected and has a mean of 0.409 centimeters with a standard deviation of 0.029 centimeters. And then we want to test at alpha equals 0.05 whether the true mean diameter is different than the 0.400 centimeter specifications. Okay, so these are like the specs. This is what it should be, and we don't know whether the true mean is that or not. That's what we're testing. So this is our hypothesized mean, and the null always says the true mean is equal to the hypothesized mean. Okay, and in this case I'm testing to see if maybe it's different than that. Okay, not necessarily greater than or less than, but different than. So this is not equal to 0.400 centimeters. So the alternative here, I want to show that the true mean is not equal to the specifications. So that makes this a two-tailed test. So when I set up my rejection region here, I have a two-tailed alpha of 0.05. Okay, so I'm going to shade two tails here, and I'm going to go to my t-table. But now the important thing here is this is a two-tailed alpha, so I'm going to look at this row for 0.05, and I see it right here, and then I go to the bottom, and then my critical z value is 1.960. So this is 1.960. This is negative 1.960. And so over here we would have reject H naught. Over here would be reject H naught. In between would be fail to reject H naught. Okay? One thing I was going to say is once you get the hang of how these work, you don't have to write this out every time. I just do that just to make things clear as we discuss it here. Okay, so now my test statistic, we want to see where it lies here. So I'm going to take the sample mean, which is 0.409, minus the hypothesized mean, 0.400. Divide this by the standard deviation, 0.029, over the square root of n, which is 45. Okay, so plugging this in, we get 0.409 minus 0.400, and I'm going to divide that by 0.029 divided by the square root of 45. And I get 2.08. And so comparing that with my rejection region, that's actually in the rejection region this time. It just made it over. So I'm going to reject H naught. And so that means I'm going to to interpret my results, I'm going to say there is enough evidence to conclude what this alternative is saying. There is enough evidence to conclude, and what am I concluding? There's enough evidence to conclude the true mean diameter is different than this specification. So I can say different than the specifications. Or if there is enough evidence to conclude the true mean is different than 0.400 centimeters, that would be fine too. But there you go. There's an example of a two-tailed test. So now in the next video, I'm going to have you do a test twice at two different significance levels. And then I'm going to want you to compare the results of the test and see if you can figure out what's going on. If the results are different, see if you can figure out why they're different. And this is going to lead in then to a discussion of the type 1 and type 2 errors.